Welcome to the week 8 problem session. So, we have 4 5 problem solving session left before we conclude this course. So, what I will do today? I guess that you need to submit the assignment number 8 tomorrow. Like, what I am doing today, I have taken some problems which are related to the problem set 8, and then what we will do, we will try to solve them one by one. So I have taken 10 problems, and that will help you to solve the whole assignment. So if you have not solved the assignment or you are stuck in some question, then these questions will be helpful in order to solve them. So what I will do, I will start with some question, and then I will ask you like how to solve them. Then we will go through the solutions. Okay. So these problem will be like some applications of Laplace transform and then the Z transform, like whatever you have learned in the week 8. Okay, so let's start with the problem number 1. So problem number 1 is, you are given some equation which is y double dash plus 2y dash plus y is equal to 3t minus t, and t is greater than 0, and you are given some initial boundary condition like y0 is equal to 4 and y dash 0 is equal to 2. Then you need to find out like what will be the value of y of 1. So uh, 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 you want to tell like how do we solve this problem? Hello, are you able to hear me? Okay, I see no response. So what I will do, I will go through the solution of this question. So what you need to do in such question, so problem is asking to solve this equation, right? So you need to find out like what is the solution, what is y, value of y that satisfies this equation. So what you do in this case, you take the Laplace transform on both the side. So let's go through the solution. So what you do, you are given y double dash plus 2y dash plus y is equal to 3t minus t, right? So what you do, you take the Laplace transform on both the side. So if you take the Laplace transform on both the side, so you first have the double derivative, and then you have single derivative, and then there is some factor of te minus t. So we already know like from the Laplace transformation properties, so how to write the double derivative of Laplace of double derivative. So what it will result in, we know if you are having the double derivative, then it reduces to p square times Laplace transform of y minus py 0 minus y dash 0. This is just coming from the properties of Laplace transform. Similarly, when you have the single derivative, you have the Laplace transform of that is equal to p times Ly minus y of 0, and then Laplace transform of y will come as it is here, and then you need to do the Laplace transform of te minus t, which is I guess straightforward now because this you have learned in your last lecture. So that will result in minus d by dp of Laplace transform of e minus t, right? So Laplace transform of e minus t is 1 upon p plus 1. So this will result in derivative of d by dp of 1 upon p plus 1, right? So from there what you can do now, you can see like you already know the value of y0 or y dash 0. So the only thing that is uh, variable here is like L of y. So what you can do from this equation, you can express like what will be the Laplace transform of y, right? So you will, after solving this, you will get this equation, which is straightforward, right? Now in order to find the value of y of t, what you can do, you can take the inverse Laplace transform, inverse Laplace on both sides, because if you take the inverse Laplace of this resultant equation, you will get the value of y of t. So how to do the inverse Laplace transform of this? So what you do, you use first the linearity property and you express this as 3 Laplace inverse Laplace of 1 upon p plus 1 whole power 4 plus 4 times inverse Laplace of p upon p plus 1 square, and similarly you have tan inverse Laplace of 1 upon p plus 1 square, right? So now you already know like what will be the Laplace transformation of 1 upon p plus 1 4. So this you can use the again the properties of inverse Laplace properties of Laplace transform, and this will result into this. So this you can write e minus t times t cube if you take the inverse Laplace transform of this. And to solve this, what you can do, you can break this part, third part, as 4 plus 6. So you can write it as 4 times inverse Laplace transform of 1 plus 1 upon p plus 1 square, and you can write plus 6 times inverse Laplace transform of 1 upon p plus 1 square, right? So what you can do, now you can add uh, like uh, you can club both of these. So what you can do, you can club this and the thing which is coming from here. So 4 times inverse Laplace of 1 upon p plus 1 square. So if you club both of them, what you will get, you will get 4 times inverse Laplace transform of 1 upon p plus 1, right? Because p plus 1 times 4 will cancel from here, so you will left with only 1 upon p plus 1. So that will result into 4 times e minus t, which is the inverse Laplace transform of 1 upon p plus 1. And similarly here you will left with 6 times inverse Laplace transform of 1 upon p plus 1 square, and that will result in 6 times t into e minus t. So this is your resultant solution, like what you get after solving this equation. Now question is asking like what will be the value of y of 1. So the value of y of 1 will be, you need to put the value of t is equal to 1 here, and you will get y of 1 is equal to 21 upon 2e. So this is the answer of this problem. So I hope you understand this problem, and if not, just feel free to ask any question and I will clear it. So if there is no doubt, what I will do, I will move on to the next question.
Yes, sir. No doubt, sir.
No doubt. Okay. I will
No
then
doubt.
move. So I will urge you to participate. So I will ask you to like how to solve next question. Maybe that will be more like engaging. So here is the second problem. So you are given some differential equation which is y double dash plus ty dash minus 2y is equal to 6 minus t, and then you are given some initial boundary condition which is y0 is equal to 0, and then y dash 0 is equal to 1, and it is given that if Laplace transform of y of t exists, like whatever is the solution of this differential equation, you are given the Laplace transform of that equation exist. So then what will be the value of y of minus 1? So how do you will solve this problem? Any are you there?
Yes, sir.
So any guess on this? So
Uh,
why do you think this is given? Like why do you think this it is given that LYT exists? So how to use that in this equation question?
First, L of y double dash substitution, sir.
Okay.
Uh,
So what you will
double
do
dash
first? You will do
formula.
the Laplace. You will take the Laplace transform of both sides, right?
Yes, sir. Laplace transform of
Okay.
both sides. After L of y double dash means L of y double dash formula is applying.
Okay.
After L of t y dash, t means minus 1 d by s multiplication.
So basically you will get the
After,
derivative of here.
yes,
Yes.
yes, sir.
And
After L of y dash is differentiation
yes.
and y formula substitution. 6 is a constant.
Huh.
L of 1 means 1 by x.
Okay.
1 by s minus L of t. T means t power and formula is applying.
Yes. Okay.
Uh,
And
after
why do you
zero
think
dash.
this is given? Like if LYT exists?
Only L of y of t value is the left side, remaining all the right side Laplace apply.
Okay, so let's go through the solution then.
Yes,
Okay, so as you said, we will take the Laplace transform of both the side. So if you take the Laplace transform on both the side, you will get this equation. Okay, so now you see here it's not very straightforward to calculate the like to express the Laplace transform in the p format. Like what you do here, you in the first question you can directly express Laplace transform in terms of p, right? So here what you see, you are getting a derivative here, right? Because you can't separate it, so you can't express it in terms of p as you did before. So what you do in this equation, you say like let Laplace transform of y be y of p, right? So you call this variable. Now you see here, if you solve this equation and put this Ly is equal to y of p, you will get this equation, right? So if you recognize this equation, so the point here is, as compared to earlier problem, you are not able to express Ly directly in terms of P because you have some derivative here, right? So in order to find L of y, you need to first solve this differential equation of order 1, right? Because this has order 1. And now if you can identify which equation is this, so this is the first order linear differential equation, right? So you know how to solve linear differential equation. So what you do in that case, you first find the integrating factor. So integrating factor here will be e power, which is a coefficient here, e power integration of 3 upon p minus p dp, right? So this will be the integrating factor of this equation. So solving this, what you get, integrating factor is p cube times e minus p square by 2. So here you have just got the integrating factor, but now you need to express y of phi first. So here we are solving the differential equation in order to find the Laplace transform of y in terms of p, so that you can take then inverse Laplace of that to find the solution here. Okay. So after this, what you need to do, after calculating this integrating factor, you need to get what is y of p, right? So now again, using the properties or whatever you have learned in the linear differential equation, you can use that, and using this integrating factor, like here what I am doing, I am uh, first using the integrating factor times whatever solution you need to find, and then this will be is equal to integration factor times the right hand side factor, which is 1 upon p 6 upon p square minus 1 by p cube, and you will get this type of equation here. And I am hoping that this is very easy to solve because this you have already learned in your lectures. So from here, if I solve this integral, which is basically solving the first order linear differential equation, I will get this y of p. Okay, so you are getting y of p like this. Okay, so now but the question is asking, now you have find the y of p, right? But now you need to find like what is the value of y of 1, right? So how to do that, like you see in this equation, this is given like L y of t exists, so that means you need to use it somewhere in order to solve the problem. So let's move forward and see how to use that. So as I told you, like here you have actually calculated like what is the Laplace transform of y here. Okay, so what you can do now, now it is given that if LYT exists using the existence theorem, here LYT exists. So what you need to do then, if I take limit p approaches to infinity upon into Laplace transform of y, then it should give me 0, right? Right? So from here, if I put p is equal to infinity here, right? So and the Laplace transform of that is 0, then what I will get? I will get value of constant is equal to 0. So basically I am saying c is equal to 0, and from here I can write what is the Laplace transform of y, right? And from there you can take the inverse Laplace transform of that in order to find y of t. So y of t will be 3t square plus t, and so question is asking like what will be the value of y of minus 1. So value of y of minus 1 will be 3 times minus 1 whole square minus 1, which is y of 1 is equal to 2. So y of 1 is equal to 2 is the answer of this problem. So I hope you got the idea, like if somewhere you are not able to express like Laplace transform directly in terms of p, then you need to first like solve this differential equation in whatever order it you get, and then you need to use like this type of existence theorem, that's why it's given here, and then you will get your answer. So is it clear, this question?
Yes, sir. Clear, sir.
Okay, so you got the idea like why lyt exist is given, right? Okay.
Understood.
Okay. Okay, then let's move on to the next question.
Okay.
So next question is, if f of t, you are given some function f of t which is equal to e power minus t minus 2 times integration of f of u cos t minus u du, then you need to find like the value of ft. So how to solve that?
Both sides Laplace transform
Okay. Hello.
minus 2 into L of f of t into L of cos.
Okay, so here you are using the convolution property, right?
Yes. Yes,
Okay,
sir.
okay. You got the idea. So let's go through the
Okay.
solution of that. So you first need to use this property where you are writing this convolution of f and g t is can be written as 0 to t fu gtu minus du, right? Now if you compare here, then you can say g of t is equal to cos t, right? And f of p will be this f of t. So from here, what you can do, if you take the Laplace transform of both these sides, you will get f of p is equal to 1 upon p plus 1, because you have e power minus t, and then minus times the Laplace transform of both ft times Laplace transform of gt. So Laplace transform of ft will be nothing but f of p, and the Laplace transform of cos t will be 2p upon p upon p square plus 1, and 2 you are getting here because it's in the coefficient of this, right? So from here again you need to do the same thing. You need to express f of p in terms of p. So f of p is equal to p square plus 1 upon p plus 1 whole cube, right? And from there what you can do, you can write also express this f of p like this, right? And here now you need to again take the inverse Laplace transform of that in order to calculate the function f of t. So you see why I subtract minus 1 from here, because then you can use the again the properties of Laplace transform, which is shifting property. So you can write f of t is equal to e power minus t times inverse Laplace transform of p minus 1 whole square plus 1 upon p cube, right? Using the properties. And then you can just separate this, and you can write e power minus t times inverse Laplace transform of 1 upon p minus 2 by p square plus 2 by p cube. And I guess this is very straightforward to solve. So after solving this, you will get f of t is equal to e power minus t times t minus 1 whole square. So I thought, I think it was a very easy problem. So I hope you got the idea of how to solve that. So any doubt in this question?
Doubt, sir.
Okay, I will move to next part. So here you are again given same type of problem. So I hope you already know, have the idea now to how to solve that. So you are given here y dash t is equal to t plus 0 to t yt minus u cos u du, right? So again here you need to use the convolution property, and then you take the Laplace transform of both these sides. So here again I am taking the Laplace transform where I am expressing ft and gt like this, and then you take the Laplace transform of derivative, which is nothing but p times lyt minus y of 0, and then L of t will be 1 upon p square, and here you can write it as a product of a Laplace transform of two function using the convolution properties. And from there again, doing the same business as we did earlier, we can express Laplace transform in terms of p directly. So the Laplace transform of this will be 4 upon p plus 5 by p cube plus 1 upon p power 5. And again, in order to find like what will be the y of t, you need to take the inverse Laplace transform of this y of p. So what you will get, you will get inverse Laplace of 4 upon p plus 5 by p cube plus 1 upon p5. And then using the standard, these are like standard inverse Laplace transform of these functions. So y of t is equal to 4 plus 5 by 2 t square plus t4 upon 24. So I hope this again was a easy problem. I just took it like as to map it to the assignment problem so that you can find it easy to solve the assignment. So I will move on to the next question now.
Yes, sir.
Okay, so the next question is, you are given two differential equation. Like first you are given dy of over dt plus 2x is equal to e power t, and then you are given dx by dt minus 2y is equal to 1 plus t, and then you are given two initial boundary condition for both x and y. So x of 0 is 1 and y of 0 is 2, and then you need to use the Laplace transform properties, and then you need to find what is the value of x of t. So how you will solve that? Just give me idea, and then I will move forward. Okay, so No answer, so I will move on to the solution. So here, first of all, you are given two equations, right? So these are like mixed equations. So like you have if you are if derivative is respect to y, in that equation you also have x, and similarly you have in the derivative of x you have y. So the simple thing to like in order to solve this problem is, you first suppose like the Laplace transform of x of t is equal to capital XP, right? And similarly the Laplace transform of y of t is equal to capital YP. Now what you do, you take the Laplace transform of both of these equation on both right hand side as well as left hand side. So if I take the Laplace transform of the first differential equation, which is dy by dt plus 2x is equal to e power t, then I can write it as this, right? L y dash t plus 2l xt is equal to L Laplace transform of e power t. And in order to like how to solve this, so here I can again use the properties of derivative. So here I am using p of y minus y of 0 plus 2x is equal to 1 upon p minus y, right? P minus 1, because if I solve this and take the uh, take the like Laplace transform of these functions, I will get this equation, right? Because I have assumed like the Laplace transform of y dash t is equal to nothing but y of p, right? So I have py minus y of 0 plus 2x is equal to 1 upon p minus 1. Similarly, I can do the same business of this for the second equation. So if I do that, I will get L x dash t minus 2L yt is equal to L1 plus LT, right? Because you are given here the same equation, I just took the Laplace transform both the side. So solving this, what I will get, I will again like using the derivative property of Laplace transform, I can write it as p times Laplace transform of x of t, which is nothing but capital X, minus x of 0 minus 2 times Laplace transform of y of t, small y of t, and on the right hand side it will be 1 by p plus 1 by p square, right? So now if you see, compare both of this equation have two variable x and y. So what you can do, you can solve this equation simultaneously. So here if I rewrite this equation by putting all the boundary condition, which is y of 0, I will get 2x plus py is equal to 2 plus 1 upon p minus 1. Similarly, I will get px minus 2y is equal to 1 plus 1 upon p plus 1 upon p square. I am using just the, I have just put the boundary condition in both of this equation. So now I can see both have x and y, right? So if I can just solve these equations simultaneously, I can just get the value of x in terms of p, because the question is asking like what is the value of the x of t. So first I will find the Laplace transform of that, which is capital X, in terms of small p, and then we will take the inverse Laplace transform in order to solve the problem. So let's go through that. So here, as I told you, what you can do, you can solve them simultaneously, and you can express one of these, which is x, by eliminating the y from both of these equation. So what you can do, you can multiply this equation, above equation, by like 2, and you can multiply the bottom equation by p, and then you can add them both, and then you will get this equation, which is capital X, like this. So now here you can again what you can do in order to solve this, you can use the like partial fraction. So after using the partial fraction, which you already know, you can express this Laplace transform of small f of x of t as capital X is equal to 2 upon 5 upon p minus 1 plus 7 by 20 times p upon p square plus 4 plus 23 by 5 upon times 1 upon p square plus 4 plus 1 upon 4 times 1 by p, right? And now the problem is like you just need to take the inverse Laplace transform of this, because Laplace transform of small x of t is capital X. So if you take the inverse Laplace transform here, then you will get x of t. So if I take the inverse Laplace transform of this complete function, I will get this equation. And I think this is now very easy to solve because these are just the Laplace transform of some standard function. So you will get x of t is equal to 1 by 4 plus 2 by 5 e power t plus 1 by 20 times 7 cos 2t plus 46 sin 2t, right? So I hope this question is again clear. So we will be moving towards the next question. Okay, so I will wait for 1 minute if you have any doubt, and then I will move forward. So I hope there is no doubt, then I will move forward. So this is the next problem. So you are given some solution of the let uxt be the solution of initial boundary value problem, and you are given the double derivative of u with respect to t is equal to double derivative of u with respect to x. So you are given this equation where you are saying the double derivative of u with respect to t is same as double derivative of u with respect to x, and you are given some initial boundary conditions. And then if L of uxt, if the Laplace transform of this solution is given by ux of p, then you need to find what is the value of ux of p. So like this type of problem is there in the assignment also. So what I will do, I will go through the solution of this guy. So let's go through that. Again, I will repeat this problem. So let uxt be the solution of the initial boundary value problem, and you are given the double derivative of u with respect to t is same as double derivative of u with respect to x. So you are given d square u by dt square.
Sir,
Yes,
the presentation not there, sir.
not
Just
there.
a voice. Hmm.
Okay, let me again share. Now it's visible.
No, no, sir.
No.
Ah, just now. Okay.
Okay,
Now, okay.
okay. So I will just repeat the problem again. So you are
Okay.
given some solution. You are given some solution ux of t, and you are given that del square d square u by dt square is equal to d square u by dx square, and you are given some boundary condition on u, and then you are given the if the Laplace transform of this solution is ux of p, then you need to find what will be the value of ux of p, which is nothing but Laplace transform of this given solution. So how to solve this problem? You have any idea? Just to get some hint, then I will move forward.
Uh, no idea, sir. These questions is very difficult, sir.
Oh, I think guess there is one more problem in the assignment also. Same problem, like this
Yes,
only.
sir. Sin 4 pi x is there, but I not solve.
Okay, so after this maybe you can solve it. Okay,
Uh,
okay. So okay, then I
yes,
will
sir.
move through the solution of this. So first, what you are given this equation. You are given d square u by dt square is equal to d square u by dx square, right? So what you can do again, you can take the Laplace transform of both these sides. So if you take the Laplace transform of this, then this you have learned in class, right? If you have like Laplace transform of d square u by dt square, then this result into this p square times u x of p, which is nothing but the Laplace transform of u small u x of p minus pu x 0 minus ut x 0, which is du by dt as a function of x and 0. And then on the right hand side, the Laplace transform of d square u by dx square is nothing but d square u by dx square, where u is the Laplace transform of this small u, right? So if you just solve use this property and put these boundary conditions, so what you are given u x of 0 is 0, right? So you can put it here, and similarly ut x of 0 is nothing but sine 3 pi x, right? So if you substitute this in this problem, what you will get d square u by dx square, if I take this first, minus p square u, where I can bring this on the right hand side, and then it will give me minus times utx of 0, and utx 0 is nothing but sine 3 pi x, right? So I can get this type of differential equation in terms of u, capital U, and this you need to find actually. So basically now you have the differential equation corresponding to u, and if you now think about this problem, this is nothing but the second order homogeneous non-homogeneous differential equation. And how to solve that? So in order to solve that, first you need to write the auxiliary equation for that. then you need to write the complementary function, and then you need to then you can solve such problem. So let's go through
Sir,
that. Yes.
one small doubt.
Yes.
Minus sine 3 pi x, how, sir?
So,
Sine 3 pi x.
okay, so just see the right hand side. So if I take d square u by dx square, okay, then I am bringing this first term here on the right hand side. So it will be minus p square u. And this term is on the left hand side only. So it will be minus times utx of 0.
Okay.
Got it?
Okay. Understood.
Okay, so here you need to again first write the auxiliary equation. You need to find the complementary function, and then you can solve such problem. So here again using the again whatever you have read in or learned in the differential equation week. So I am using that only. So I can write this as d square, right? Because u I can take common. So I can write it as d square minus p square times u is equal to minus 3 times sine 3 pi x. So what you do in order to solve such problem, you first just find the auxiliary equation of left hand side, then you write the complementary function, then you calculate the complementary integral for the right hand side also, and then you take the superposition of those two complementary function and the particular integral, and then you will get your answer, which is nothing but u. Okay, so here if I solve this just the auxiliary equation, what I will get m square minus p square is equal to 0, right? And solving this, what I will get m is equal to p and minus p. So basically what you have two roots which are both real and distinct, and in that case the complementary function can be written as c1 times e power m1x, m1 is nothing but p, and plus c2 times e power minus x. So basically now you have calculated the complementary function, but now you need to, in order to solve this complete differential equation, you need to have the particular integral also. So again using what you have learned in your lectures, I can write the particular integral as function on the right hand side, which is nothing but minus sine 3 pi x, and divided by d square minus p square, right? And then again using the property, when this d square act on the sine part, you need to replace d square by minus a square, right? Where a is the argument of this. So if I replace d square by minus 9 pi square, right, because a here is 3 pi, and I need to replace d square by minus 9 pi square. So if I replace d square by minus 9 pi square, then I can cancel minus sign from both numerator and denominator. So what I will get? I will get pi is equal to sine 3 pi x upon 9 pi square plus p square, right? So now the complete solution of this non-homogeneous differential equation can be written as the complementary function plus the particular integral. So the complementary function is c1 times e power px plus c2 times e power minus px plus particular integral, which is nothing but this sine 3 pi x upon 9 pi square plus p square. Now the only problem remain is to calculate this value of c1 and c2, and that is very easy to solve, because what you are given two additional boundary condition. So these two boundary condition you have used, right? But you have not used these boundary condition. So you are given u0 of t is equal to 0 and u1 of t is equal to 0. So here if I take the Laplace transform of just this, okay, so what I will get capital U 0 p is equal to 0, and then if I again take the Laplace transform of this, I will get u 1 of p is equal to 0. Now you have these two new boundary conditions. So what you can do, you can just put the value of x is equal to 0 in this first and equate it to 0. So what you will get from that, you will get c1 plus c2 is equal to 0. And if you use u1 of p is equal to 0, you need to again put value of x is equal to 1, and from there you will get c1 times e power p plus c2 times e power minus p is equal to 0. And the only solution of these two, if you solve them simultaneously, will be c1 is equal to 0 as well as c2 is equal to 0. If I put c1 as well as c2 is equal to 0, the ux of p will be nothing but sine 3 pi x upon 9 pi square plus p square. So I hope you got the idea to solve this problem.
Understood, sir.
So now I guess you can solve the assignment problem also,
Yes, sir.
because
Already completed, sir. Now.
okay, okay. So I will move on to the next problem then.
Yes, sir.
Okay. So here, like this was all about the what you have learned in the Laplace transform, as well as the application as well as the properties of that. So now we will start with the some problem of the Z transform, because I see there are some problems of the Z transform in the assignment as well. So we will go through this question one first. So what you are given this sequence u of n, which is nothing but sine of 2n minus 3, and then you need to just use the formula of z transform in order to solve this problem. So I will just directly go through the solution because I know it's a easy problem. You just need to know like what is the formula to find the z transform. So here first you are given sine 2n minus 3, right? So again using the like the exponential properties, you can express this sine 2n minus 3 as a in terms of this complex exponentials, right? If I use Euler's identity, I can express sine 2n minus 3 in terms of this, right? So basically you need to find the z transform of this function, right? So again you can use the linearity property first as you do in the Laplace transform. And so here what you can do, you can bring this 1 by 2 iota outside, right? So now first you will use the formula of z transform of this, and then you use the formula of z transform of this. So the formula of z transform is summation n 0 to infinity e iota 2n minus 3 times z power minus n, right? So first you write the sequence whatever you are given, and then you will write z power minus n. Similarly you do on this side. So first you write the sequence and then you take z power minus n, right? So now what I can do, I can bring this e power minus 3 iota outside here, and then you can do the summation from n0 to infinity. You will get e power 2 iota upon z power n, right? If I just rewrite this. And similarly, you can bring the e power 3 iota here. Now this is nothing but a geometrical progression, infinitely geometrical progression series, and for that you can easily write like what will be the summation of this infinite series using the geometric progression formula. So here I am directly writing this. So you will get e power minus 3 iota times z upon z minus e power 2 iota minus e power 3 iota times z upon z minus e power minus 2 iota, with modulus of z is equal to 1, which is confirming that this series is converging to somewhere. Okay, so again you can again rewrite this problem, rewrite this equation like this, and again you can use the Euler's identity to express these exponential in terms of sign again. So here the z transform of this sequence, which is nothing but sine 2n minus 3, will be minus times z square sine 3 minus z sine 5 upon z square minus 2z cos 2 plus 1. So it was just a straightforward problem of calculating the z transform by using a simple formula of z transform. Is this clear? Hello?
Clear, sir.
Okay, then I will move on to the next problem. So the next problem is again like same, some sequence is given to you, which is nothing but cos n pi by 2 plus pi by 3, and you need to calculate the z transform of this sequence. So again you need to use the same properties. First you need to express it using the Euler's identity. So it's really easy to express cos in terms of this exponential by using Euler identity, and you can express this. And again then you need to use the formula of the z transform. So again I am skipping this part. So here you can write e power iota pi by 3 outside, and then again write the summation n 0 to infinity e power n pi by 2 times z power minus n, and same business here. And again you do the like the infinite geometrical progression. You write the summation of this like this, which is nothing but e power iota pi by 3 times 1 upon 1 minus e power iota pi by 2 z. Again saying modulus of z is 1, again just to say like this series is getting converged somewhere. And after you can again rewrite this problem by taking the z in the numerator and denominator here, and you will get this type of equation. And then you can take the LCM of that, and you can rewrite this equation like this. And again you can just put the value of e power iota pi by 3. So what is e power iota pi by 3? It's nothing but cos pi by 3 plus iota sine by 3 pi by 3. So you basically substitute both the values of these exponential in this problem, and you will get this answer. So the basically the z transform of this sequence, which is nothing but cos n pi by 2 plus pi by 3, is nothing but 1 by 2 times z times z minus root 3 upon z square plus 1 with modulus of z more than 1. So is this question clear? Although the same
Clear, sir.
problem. Okay, I will move on to
Same
the
type.
yeah, next problem. So here you need to, you are given some u of z. Now you are given the z transform of some sequence, right? So which is given by u of z is 5z upon 2 minus z upon 3z minus 1, and you need to use the inverse z transform in order to find the sequence. So first the sequence was given, and you found the function by taking the z transform. Now some function is given and you need to find the sequence. So let's go through the solution, and I know you it's a really easy problem, but just I will go through the solution. So what I can do here, I can bring this z down here, so I can write it as u z by z upon 5 upon 2 minus z upon 3z minus 1, right? So I can now again use the partial fraction properties, and I can write it as like this, right? So again, I can rewrite this as uz is equal to z upon z minus 1 by 3, and similarly I can write it as minus z upon z minus 2. And if I take the inverse z transform of now both right hand side and left hand side, what I will get? I will get inverse z transform of u of z is equal to inverse z transform of z upon z minus 1 by 3, and here you will get inverse z transform of z upon z minus 2. And by inspection only you can see that this sequence, if you take the z transform of 1 by 3n, you will get this z transform, and similarly if you get the you do the z transform of 2 power n, you will get this type of function. So basically the un after taking the inverse z transform of this uz will be 1 upon 3n minus 2 power n. So is this question clear?
Clear, sir.
Okay, then I will move on to the last question of today. So here you need to use the convolution theorem, okay, and then you need to find the some sequence. So if you take the z transform of that some function, you will get some sequence. So any thought on how to solve that?
Sir, actually, this is a partial fractions after the same before some type like sir.
Hmm? Same problem is there in the assignment, I guess, right?
Yes, sir.
So you have solved that.
Yes, sir. Completed.
Okay, then I can go through the solution directly, right? Okay, so what to do in this problem? So first you need to again take the inverse z transform of this complete capital uz. So you can write it as 12z square, and then 3 you can take common, and then you can write it as 3 times z minus 1 by 3 times 4 upon times z upon 1 z plus 1 by 4, right? And then you can again rewrite it as, because you can cancel 12 and 12 on both numerator and denominator, so you will get inverse z transform of z square upon z minus 1 by 3 upon z plus 1 by 4, right? So here what you can do, you can again use the convolution theorem of the z transform, and you can rewrite it as like this. So basically you can take one function as z upon z minus 1 by 3, and you can take other function as z upon z plus 1 by 4, and again you can use the convolution theorem of z transform. You can write it as a convolution of z transform, inverse z transform of z upon z minus 1 by 3, and inverse z transform of z upon z plus 1 by 4. So if I just now take the inverse z transform of this function, I will get this sequence 1 by 3n. Similarly, if I take the inverse z transform of z upon z plus 1 by 4, I will get minus 1 by 4 power n, right? So now the only thing remain is to calculate the convolution of two sequences. So you have 1 by 3 power n convolution with 1 minus 1 by 4 power n. Okay, so I can also rewrite it as like this, minus 1 by 4 power n is star 1 by 3n. So now if you recall the convolution property for the continuous functions, so when you were reading this Laplace transform, there you do the integration. But the fact that this is not now a continuous function, it's a discrete function, so you need to use the property of summation, right? So as you do here, so there, so what you do, you first write f of t, then gt minus u du integration. So same you do here, but you do as a summation because this is a discrete. not, it's not a continuous function as you did earlier. So here what you need to write summation with some variable r which is going from r0 to n, and then you write it as first function in terms of r, like as you write there f of u, right? So you, I write it as minus 1 by 4 power r, and similarly I write 1 by 3 power n minus r, as you write there gt minus u. So I just replace n by n minus r because there you replace t by t minus u. So here I am just using the convolution property of two discrete sequences, and I can rewrite it as like this. So after this I can, because this summation is on r, right? So I can bring this 1 by 3 power n outside, and I can again write the summation r0 to n minus 1 by 4 power r times 3 power r, right? So I can again rewrite it as like this minus 3 by 4 by taking a common power r outside. Okay, so now I can again use the geometrical progression. So earlier we were dealing with the infinite geometrical progression, but here now you need to take the geometrical progression from r0 to n, right? So I can write it as 1 by 3 power n, and I just write few terms for the summation by putting some values of r. So if I put r is equal to 0, I will get 1. If I put r is equal to 1, I will get minus 3 by 4, and similarly you go on till you put n. So basically if you see now, there are n plus 1 terms total in this, and if I use the series formula of the geometrical progression, I will write 1 minus r upon n plus 1. So r is the ratio, like ratio here is minus 3 by 4, so you will write minus 3 by 4 power number of terms. So number of terms are n plus 1, and in denominator you will write 1 minus r. So r here again is minus 3 by 4, so you will write 1 minus minus 3 by 4. And so I hope this is clear. So if I move forward, I can rewrite it as, so what I can do, I can bring some term outside, so I can write 1 by 3 power n 4 by 7 times 1 minus minus 3 by 4 power n times minus 3 by 4. Then I can write it as 1 by 3 power n 4 by 7 3 by 7 minus 3 by 4 power n, just using some algebra. And then I can take this 7 outside, 1 by 7 1 by 3 power n 4 minus minus 3 by 4 n upon n plus 1. So is this question clear? The only thing was to
Clear, sir.
use this like how to write the convolution of two sequences and how to use the convolution theorem for the Z transform. So this was all about this some problem for the assignment number 8. So I hope you got some idea, and now as you need to submit the assignment tomorrow, so I hope this was helpful for you. If you have not solved some problem, and then you can revisit this assignment, and then you can solve them and submit them. So do you
Sir,
have, yes?
sir, your mail ID I forgot, sir. Give me a mail ID.
Sure, sure, I will. And I told you to like